It's the 17th century supernova that nobody saw, but telescopes in space and on Earth have teamed up to look back in time and study it today. When a massive star reaches the end of its life, it explodes dramatically, and for a few months can outshine everything else in the galaxy. But the Cassiopeia A supernova remnant is a bit of a mystery. Astronomers have concluded it should have been visible sometime in the late 17th century, but there are no clear historical references to it. A team led by astronomer Oliver Krause has, over the last few years, made a remarkable series of infrared observations of the region. The Spitzer Space Telescope images show shifting patterns of glowing dust beyond the remnant itself. These changes are so fast, they indicate motion at the speed of light. To get to what's happening, we have to remember that light is fast. But in such a huge galaxy, it still takes a while for it to get anywhere. Cas A is 11,000 light years away, which means that we're seeing it today the way it was 11,000 years ago. But that's only part of the story. Light from a supernova can even take hundreds of years to reach surrounding dust clouds. Following the arrows of light, it's clear we'll see the supernova flash first. The light echoing off the dust clouds will arrive later at various times, delayed by hundreds of years from the original flash. So we're not seeing the dust move. We're seeing the light from the supernova move through the dust. Out there, the flash is about as bright as the light of the full moon, which is enough to warm the dust ever so slightly. Spitzer, in turn, can observe this brief jump in its thermal infrared glow. Now, knowing the location of the infrared light echo, Dr. Krause and his team went searching for a far more elusive, visible light echo. Using the powerful Subaru telescope in Hawaii, they succeeded in measuring the very faint light of the supernova itself, reflecting off the dust. The light echo has acted like an astronomical time machine, letting us study the original supernova using instruments that were beyond imagination in the 17th century. By matching its visible light spectral signature to a well-studied supernova in a nearby galaxy, Krause and his team have identified it as a so-called Type 2b supernova. A Type 2b is fainter than the earlier Type 1b supernovas noted by Tycho Brahe in 1572 and Johannes Kepler in 1604. Interestingly, the Royal Astronomer Flamsteed noted a star near Cas A in August of 1680 with a brightness consistent with a Type 2b supernova at that distance. So, maybe it was seen after all. But this light echo also reveals more than just the supernova. The expanding flash also lets astronomers study the three-dimensional structure of the dust by illuminating it one slice at a time. If we combine the images, assigning colors to the observation dates, the result is a prismatic display of the 3D dust structure. The nearest dust is blue, and the most distant is red, while everything that stays constant is gray. We can see that the interstellar dust lies in sheets and filaments, not, for instance, big puffy clouds. This remarkable light echo around Cas A has led to a better understanding of both supernovas and interstellar dust, which itself is made of elements that were forged in previous generations of supernovas.
The Hidden Universe is produced by the Spitzer Science Center at the California Institute of Technology in Pasadena.